finally, there's one last oddity that arises in the syntax for declarations, and that is in some contexts you need to declare a pointer, but there isn't any name for the asterisk to operate upon. This happens when you wish to cast to a pointer type, and it also can happen in a list of parameters. When we're not defining a function, when we're just declaring a function, or when we're declaring a pointer to a function, we end up with a parameter list where the parameters don't have names, and so how do you then declare a pointer for a parameter type? Well, in the simple case, you're just declaring a simple pointer, or a pointer to a pointer, or a pointer to a pointer to a pointer, or some degree of pointing without involving any arrays or pointers to functions or anything like that. In these cases, you just write the asterisks as if the name is there even though it's not. So for example, if you want to cast the expression foo into a pointer to a pointer to a pointer to int, then you simply write in parentheses int with 3 asterisks. However, if you want a pointer to an array or a pointer to a function, you need to somehow specify that the asterisk is what is read first, and so we put it in parentheses. In effect, the asterisk almost acts like the substitute for the name upon which everything is operating. So here, to cast the expression foo into a pointer to an array size 8 of chars, we write char and then in parentheses an asterisk and then the subscript with 8. And because the asterisk is inside parentheses, it is read first. Otherwise, this would be a cast to an array size 8 of pointers to char, and that doesn't make any sense because you can't cast into an array. Lastly, let's say you want to declare a function foo which returns float but takes a pointer to a function returning int. Well, again here we simply put the asterisk in a pair of parentheses, and now it's as if the parameter list parentheses to the right are operating upon that expression, the asterisk in the parentheses. It's acting as a sort of stand-in for the missing name. Speaking of function declarations, we can now finally get into their significance. First of all, when the compiler looks at a file of source code, it expects everything to be declared before it is used. So here in this example we have a problem. We have 2 functions defined, one called foo and one called bar, and as I mentioned in passing, a definition in C is always implicitly a kind of declaration. So when we define foo, we are implicitly declaring it, and when we define bar, we are also implicitly declaring it. The problem here is that in foo we are invoking the function bar, but the function bar is not declared until after the function foo. Now in truth, this aspect of C compilers is really quite stupid. There's no reason you can't write a compiler that will simply look ahead in code until it finds something that it previously has been used but not been declared. The reason C compilers don't do that is mainly historical legacy. It's because back in the 70s computers were much slower, and when compilers do that behavior, when they look ahead in a file, that takes more memory and processing power, and so the decision was made that a C compiler should be what's called single pass, meaning when it reads the code it can start at the top and just chew its way through without backtracking or jumping forward. So to deal with this quirk in this example, we could simply reverse the order of the definitions such that bar comes before foo. Another way to do it though is to simply, before the use of bar, declare what bar is. So now when the compiler sees the invocation of bar, it's satisfied because it knows what bar is. Here we've put the declaration inside the function foo, and so that declaration is only known within that function. If we put the declaration outside any function, then it is visible to any functions that follow it in code. This is more generally useful, so most commonly this is the way it's done. Function declarations also have great significance when it comes time to compile and link our code. Recall from a previous discussion that C code gets translated into an executable by first taking the source files and individually compiling them into object code files, and then taking those object code files and running them through the linker to produce an executable. Because each source file is compiled separately, when you define a function in one file and want to invoke it in any other, you have to declare the function in those other files. So here, for example, we have a file main.c and a file foo.c, and in foo.c we define a function named foo, and if we want to use that function in main.c, we have to declare it in main.c. It's important to note that the reason this works is because when object code files are linked together, everything in those files effectively gets smashed together in one big namespace. That's why the function foo defined in foo.c is recognized by the linker as the same function foo declared in main.c. On the downside, it means that when you link together a bunch of files, you have to make sure that any name used for a function is unique. If the compiler sees two competing definitions for the same function, that's a namespace collision, so it causes a compile error. This lack of namespacing at the file level is pretty much an out-and-out mistake. Virtually every language created in the last 20 years or so has provided a mechanism for neatly organizing things into namespaces such that not everything in your program is smashed into just one big giant one. As annoying as this lack of namespacing may be, it's not an insurmountable problem, and one way programmers in C cope with the lack of namespaces is that when they create, say, a library of functions, they make sure to name those functions with a prefix. For instance, in the OpenGL library, a library having to do with 3D graphics, all of the functions begin with the letters GL. And this very significantly cuts down on the likelihood of any name collisions when that library is brought in and linked with other code. Like, say, in your code you might create a function which you call drawElements, but it's very unlikely that you're going to create a function and call it GL drawElements. So the chance of a namespace collision with this library is therefore much more remote. In the eventuality you ever do encounter a namespace collision, the solution is to simply rename one thing or the other.